Hi everybody, it's term 4, yay! Which means it's almost over. So we're going to continue with the exam prep. Today we're going to do some equilibrium stuff. Let's see how we go with that. So I'm going to put this question up. And I'm going to give everyone 3 minutes to have a go. So, short answer question. This will require from some skills from Unit 3. And I'm going to give everyone 3 minutes to come up with a balanced equation. And then we can go from there. Turn it down my cloth. If you figured it out, guys, just chuck in the chat. If not, yep, Kai, can you make sure when you write that? So Kai is correct. Stop sharing so you guys can. So the question tells us well, stop having a mental breakdown. Carbon dioxide gas, just CO2. You'll only get half a mark if you don't put the states in. It's super important for any kind of reaction where you're talking about equilibrium. Reacts with H2 gas to produce carbon monoxide gas and we have liquid water or water vapor. So again, so half a mark for the balanced equation, the other half would be for the correct states. And we can count out that that is a balanced equation. That's the answer to A. You'd be surprised how many of my students get to this point and they forget how to write a balanced general equation. do not be afraid to go over the basics. And we will spend one of these seminars going over the basics before the exam. All right, we've got another couple of minutes for question B. So equilibrium content is Kc. So I think I might give 2 minutes for this one, maybe 3. Depends how nice I feel. One more minute. So if anyone wants to put chat, how do we write the initial equilibrium expression? What's the first thing we write? So calculate and to get full marks, we would have to write Kc and we'd have A or we would have products over reactants. This one is nice and easy because the superscript number is just going to be 1. So we're dealing with gases, so the concentration is moles per liter. So we need to write the concentration of each of the reactants. CO2, so if you guys want to do this whilst you're following along with me, we've got CO2, H2O, CO, at H2. If we read the question, what's the volume of the vessel? Just realized that. So what's the volume of the reaction vessel? So 4 liters. So each of these molar concentrations needs to be divided by 4. So CO2 is 0. What do we got? I'll just do this so you guys can see on my screen. 0.3186. .3186 moles. But we have to divide that by 4 liters. H2O gives us 0.1816. Divided by 4 liters. CO is 0.0184 divided by 4 liters. H2 is 0.1816. Again, to get full marks, you need to put the appropriate thingies. Now my brain's working good today. Units, sorry. So that gives us, did these calculations earlier, 0.0954 moles per liter of carbon dioxide, 0.0454 for H2O. Carbon monoxide is 0.046. 5. So to put these back into our equilibrium expression, we have products over reactants. Easy here because all of the molar coefficients are 1. That makes it much easier. So we would have 0.0046, which is the first the first product, times by 0.0454, which is the concentration of the second product, which is water vapor, divided by 0.095 times 0.0454. So concentration of carbon monoxide times by the concentration of H2 of H2O, sorry, that's H2. If we put that into our calculator, what does that give us? So that will give us a Kc value of 4.10 to the minus 3. So that's how you calculate equilibrium constant. It's product 1 times product 2 in moles per liter. Divided by reactant 1 times by reactant 2, again in moles per liter. All right, and there is a part C to this question. So, what would the effect of adding a drying agent? I'm not going to tell you what a drying agent is. You guys should be able to figure that out logically, looking at the balanced chemical equation. So, what effect will adding the drying agent have? And what effect will that have on equilibrium? We've got 2 minutes for this one. Any ideas? All right, so if we add a drying agent to this reaction, what we're doing is removing water. Now, water is a product in this reaction. So what do we get? What effect will removing a product have on the direction of the equilibrium? Is it going to go in the forwards direction or the backwards direction? It's going to go forwards to make up for the fact that we have removed a product. If we removed a reactant, it would go backwards. All right. Look at some esterification. This will definitely be on your exam. So 1 mark question. I'm going to give 2 minutes. What I want you guys to think about is, it doesn't have to be perfect, but what do we need to make an ester? What are the 2 organic molecules we need to start with? Can you guys see the esterification question? Not done, man. Sweet. All right, Kai, what do we need to make an ester? So Kai is correct. We need an alcohol and a carboxylic acid. What do we call, what would be an example of a name of an ester, Kai? Sorry, Kai. An example of a name of how we name esters, what do we call them? or just what like the generic name. So it's one carbon and then two carbons. We call that methyl ethanoate. So to create an ester, we could use the following equation. So we need an alcohol. So stick with ethanol, CH3, what's the functional group? What do we call it? Carboxylic acid? Cool. So we have ethanol plus methanoic acid. There are two reactants. This would give us, I know I'm not right, I need a wider whiteboard. This would give us because an ester is Couch it would also give us the formation of water. So this would be methyl ethanoate. So that's how we create an ester. Alcohol, carboxylic acid, and you get a join onto the oxygen of the alcohol and it creates Couch. It's a condensation reaction, so we get the formation of water as well. But going a bit slower than I anticipated. Question B. So very specific set of conditions required for esterification. I'm going to go a minute and a half. This one more minute actually. All right. So, esterification is conducted under reflux conditions or progressively heating something to quite a high temperature. It's also done in the presence of sulfuric acid. And Kai, if we're wanting to favor the products in this reaction, could we just add an excess of carboxylic acid? Would that then shift the equilibrium towards the product? So because this esterification reaction doesn't produce much, we want to shift the equilibrium to the right by adding an excess of acid. Adding more reactants will produce more products. That's your 3 bumps. Reflux reaction under acidic conditions, and you start with a higher volume of acid than you do alcohol, which shifts the equilibrium to the right. All right, let's go to question C. 1 minute. Dealing with heat, acid, and alcohol, what are the things you need to think of? Okay, you're dealing with heat, don't burn yourself. Dealing with acids, don't spill them on yourself. Dealing with alcohol, which is flammable, use a heating block rather than an open flame like a Bunsen burner. All right, last question for the day. So, structural formula is this here. So here we have our saturated hydrocarbon plus chlorine gives us a haloalkane and hydrogen chloride. Unsaturated hydrocarbon, give you a massive hint, just use ethene. So what will we get if we reacted ethene and chlorine? What would the product be? And you guys have got 2 minutes. Okay, so we have an unsaturated hydrocarbon. Ethene. We add our chlorine. So what's going to happen to our double bond? Any ideas? It's going to be an addition reaction that we're going to break the double bond. And we're going to stick our 2 chlorine molecules, and we're going to go back to a dihaloalkane. So this is our reaction with an unsaturated hydrocarbon. You can see the example here. Where you have saturated hydrocarbon. Any idea why the unsaturated hydrocarbon will react differently? Yep, we've got double bonds. So double bonding is an extra 2 electrons. Electrons will, having the extra electrons there. So actually, let me go back a little bit. In order for this first reaction to happen with the saturated hydrocarbon, what we need to have happen is we need to add UV light. So in order to react ethane with chlorine and create chloroethane, we need the presence of UV light because there's nothing to stimulate the reaction. When we have ethene, the additional 2 electrons they basically make it more reactive. So this reaction happens under standard laboratory conditions, doesn't require anything. And that's because the extra localized electrons provide instability. So if, like with chlorine, we know chlorine is in group 7, they are what we call electron acceptors. So electron acceptors, and pretty well anything that can accept an electron will break that double bond. So any of the halogens, oxygen will do the same thing. Yeah. All right, I think we'll leave it there today and keep working our way through these exam questions. We've got 5 more weeks to go, I think. I'll probably hold a couple of extra of these at no cost before the exam, so you guys can come in and we can just chat and have a go at some exam questions, anything you're particularly struggling with, and then before you know it, you'll all be done. And I will see you guys next week.